Speaking about design decisions that seems to be random, right? I think one of your key message when I look at the articles that you wrote is about getting to understand the context. Architecture is about context, right? So all these seemingly random decisions probably at that time is not so random. Maybe can you elaborate more what you mean by architecture is actually context?
Yeah. So when you learn software design, you learn a lot of good design principles. Depending on the sort of school of thought, you either learn how to decompose the responsibilities of a new system into several components, or you learn how to basically look at common responsibilities and design classes and objects and relationships between those. And there's a lot of good design principles, such as information hiding. If you hide the information that's inside an object from the outside world, then that means that you have a lot of freedom in rearranging that information as long as your interface to the outside world stays the same. So that's one example. Another example is low coupling and high cohesion. And those are all good design principles that, of course, every software developer and architect should know. However, to me, it becomes architecture if you do not just look at these generic good design principles, but you actually look at the business context in which you apply them. So justifying a particular choice in your design by saying, yeah, this choice leads to high cohesion and low coupling, right? For an architect, I don't think that's good enough. I think you actually need to show how in this particular system, in this particular business context, with these drivers, that is actually a better choice than doing it the other way around, because every design choice that you make has alternatives. And you can only make the right trade-offs between these alternatives if you know the context drivers. These can be commercial drivers. It can be time pressure. They can be technical drivers. If you look at, for example, design principles such as information hiding, that's a very good design principle. If your goal is to be able to modify the software easily later on and to have few dependencies between what's going on inside such a module and what's going on outside it. But sometimes that is not so important and something else may be much more important, such as delivering something on time. Those are the trade-offs that you have to make as an architect. And this is why I keep saying architecture is context. And that leads to all kinds of other good practices or things to avoid. So it means that as an architect, you should not hide in your ivory tower and just make great designs because you can't. You cannot make the right trade-offs if you don't talk to the business people or the business stakeholders, as well as the technical stakeholders that can tell you what are the important drivers in this particular situation.
So I think it's very important that you mentioned the keyword trade-off, right? Because at the end of the day, it's about multiple different factors. You mentioned about commercial aspect, maybe time, maybe technologies that are available at that point in time. And you mentioned sometimes all these requirements actually can seemingly be in conflict with each other, which makes it sometimes difficult as an architect or technical leader to make decisions. Maybe can you tell us more about how can an architect actually be able to make good decisions out of these sometimes seemingly, in conflict requirements?
So that requires a number of steps. Of course, first you need to understand these requirements and how they can be conflicting. Some requirements never conflict, like functional requirements, what we want the system to do. It's either they have to do this or they have to do that. They cannot be conflicting, right? It's either it leads you to that restaurant or it leads you to that restaurant if you're looking for a restaurant. But the conflicts arise actually in the other requirements, the ones that are not just about plain functionality, which we often call non-functional requirements, but actually a better name is quality attribute requirements. And these are things like performance or modifiability or usability, etc. This is where the architectural trade-offs really come into place. And there's another category of non-functional requirements, or some people call it constraints, which have to do with delivering on time or creating the software with a certain group of people. Some people call those extra functional requirements, or I like to call them delivery requirements. And those are the things that really drive the architectural decisions. It's very rare that just the plain functionality, the functional requirements drive the architecture. So you have to understand this. You have to understand what are these non-functional drivers. That's step one, because that will lead to the criteria that you will use to make your decisions. Then, of course, you have to also be aware of what are the various choices that you have. If you make a decision to go for something that you think has only one alternative, or if there's only one choice, that's not a decision. Decision is if you have several choices. So in order to make the right decision, you also need to make sure that you are aware what are the choices that you have. What are choice A, B, C, and D that I have to choose between? For example, what is a good development language for this particular system? Should we go with Java or should we use Python? Or actually, should we not use a development language at all, but go for some low code or no code option and just configure some existing thing? Those are alternatives that you have to choose between as an architect. If you are lazy in the sense of, okay, Java worked the last time on my last project, so I'll just use Java again, and then use some generic design principle that says that Java would work here for this, you actually have a risk of missing the best choice there. So a good architectural decision also mentions or takes into account the choices that you did not make. And then once you have the criteria based on your architectural drivers, usually non-functional requirements, and you have the choices that you have to pick between, then you have to make the trade-off. This, again, is something that is very hard to do on your own. Actually, it's probably impossible to do on your own, because now you have to see what are the impact of every choice on the various criteria that you're using to make that decision. That's not something I think that a technical person should do, unless, of course, it's just technical criteria. Like, does the platform support this kind of messaging protocol, which is required? Yeah, okay, that's a very technical criteria. But if it's about more business-like architectural drivers, such as affordability or maintainability, then you need stakeholders to make the decision with you. So most architectural decisions actually are made not just by one person or one architect, also not just by the team, the technical team, the agile team that is creating the software. They are mostly made together with other people. And this, I think, is the core of the work, or what we call the tech lead function in a team. I don't think the tech lead or the architect should necessarily have the mandate to make all architectural decisions, because sometimes they have a big impact on money, for example, and on risks. But they certainly are responsible for making sure that architectural decision is made and that the right people are involved and aware of the trade-offs that they have made.
So speaking about asking other people, I think sometimes maybe it's anecdote, right? So when you ask business people, what do they want? They want everything, right? I want speed, I want fast, I want a good UI, UX, I want slick, whatever that is. So, and you mentioned one key point that which I think is really important. A good architect needs to always keep asking the business why. Maybe, I don't know, using 5 whys or whatever number of whys. But why do you think this technique actually matters for an architect as well?
Well, I think just knowing what the business needs is not enough to make the right trade-offs. You need to know the reason why they need it, because that's where the real architectural drivers usually are. They can tell you, okay, I need Microsoft Teams in my landscape now. And that may be the right choice, but we don't know unless we also know why they think they need Microsoft Teams rather than Google Meetup or WebEx. So we cannot help them with that decision unless we know why. Yes, of course, they say we want everything, but they only say that they want everything because they are unaware of the trade-offs. Every choice that they make has drawbacks. And I think it's our job to point out those drawbacks to them, specifically to point out those drawbacks and those trade-offs in their language. If we say you have a preference for this particular way of doing it, but it leads to a more complex system, you're not going to convince them. They're not worried about the system being more complex. They say that's your job. You're the architect, right? You're the technical person. So you deal with the complexity. Why are you bothering me with that? But you need to translate that complexity into what it means for the business. A more complex system means that it's going to probably take more people to keep the complexity under control. So it's going to be more expensive. But maybe even more interesting for the business people is actually it increases the risk of bugs. Because in a more complex system, we cannot always oversee the whole impact of a particular change. A seemingly simple change may actually impact a lot of other components, which means more work. So once again, more expensive, but also more risk because there are extra dependencies and we may miss a dependency or an interface may change that we are not aware of, etc. So if we translate those trade-offs into business terms, then we help them be involved in the decision of making the right architectural choice, the right design choice, instead of just being annoyed that they want everything and don't understand everything. I once was at a Saturn conference and there was a presentation by a guy called Jochem Schulenklopper. The name of the presentation was Why They Just Don't Get It. It was a great presentation about how architects sometimes seem to think that the business people are stupid because they don't understand. It's the other way around. It's our responsibility to make them understand the impact of what they want. And so we need to talk their language rather than just be annoyed that they don't speak our language.